Hello everyone, let us talk about RedCap UE today. RedCap UE, as we know, RedCap stands for Reduced Capability UEs. In this presentation, we will be discussing about requirement for RedCap UEs, some of the use cases, 3GPP specification and definition, RedCap versus eRedCap or enhanced RedCap UEs, some parameters related to these UEs, and network access. 5G offers enhanced mobile broadband for high-speed data experience and ultra-reliable low-latency communication for critical applications. These two applications requires power-hungry and complex devices. However, there is also application for massive machine type communication for connecting a multitude of low power devices. There is a gap exist between the complex power hungry EMBB devices and the simpler lower capability MMTC devices. To fill up this gap, 3GPP has specified RedCap UEs. This image from 3GPP summarizes where RedCap UEs fit between EMBB URLLC, high performance UEs, and EMTC or NB-IoT, less complex UEs. NR RedCap UEs will play a large part in growth of 5G as wearables for medical, business and personal monitoring on stream. On an industrial scale, the other area of major growth will be the use of RedCap sensors for campuses, factories and large private sites. RedCap UEs may primarily serve these three use cases: connected industries, smart cities, and wearables. We'll be discussing these three use cases in details in the subsequent slides. Let us discuss about connected industries in detail. One key goal of 5G is to help industries stay connected. 5G can spark a new wave of changes and digital improvements in the industries, making them more flexible, productive, and efficient. It can also help cut down on maintenance costs and make workplace safer. And to achieve these, devices like pressure sensors, humidity sensors, thermometers, motion sensors, actuator, etc. play a big role. It is desirable to connect these sensors and actuators to 5G radio access and core network. Point to note, the requirement for these services are higher than MMTC or existing IoT devices, but lower than URLLC and EMBB devices. Smart city. Smart cities rely on vast network of sensors and devices which are collecting data on everything from traffic flow and air quality to parking availability and waste management. This data needs to be transmitted efficiently and reliably, but with varying requirements depending on the application. MMTC devices are designed for very low data rates, suitable for sending small data packets like basic sensor readings. However, some smart city applications like video surveillance or real-time traffic monitoring, these might require transmitting larger data streams. RedCap UEs offer a middle ground with moderate data rates sufficient for these needs. While for MMTC devices, latency is not critical, but for some smart city application like smoke detection, these require near real-time data processing. Again, RedCap UEs offer low latency compared to MMTC, which enables faster response times for these kind of critical situations. Finally, wearables. This use case includes smartwatches, rings, e-health related devices, and medical monitoring devices. RedCap UEs are ideal for wearables due to their low power consumption, translating to longer battery life. Their simpler design keeps them compact and potentially lower cost, making them suitable for integration into various variable form factors. Additionally, they offer sufficient data rates for many variable applications that don't require super fast connections. Study done in 3GPP release 17 related to reduction in UE complexity and power saving aspects. Some of the major topics evaluated in release 17 study phase were related to reduce maximum UE bandwidth, minimum number of RX branches, and maximum number of downlink MIMO layers. After the completion of the study, it was determined that maximum bandwidth of an FR1 RedCap UE would be 20 MHz and FR2 RedCap UE would support maximum of 100 MHz. The minimum number of RX branches supported for a RedCap UE is 1 as compared to 2 or 4 RX branches in NR-UE. RedCap UE with 1 RX branch will support 1 downlink MIMO layer, while RedCap UE with 2 RX branches will support 2 downlink MIMO layers. Support of 256 QAM in downlink is also optional for an FR1 RedCap UE. As far as power saving is concerned, the extended DRX cycles are introduced for RRC idle and RRC inactive state as an optional feature for RedCap UEs. However, this can be useful for RedCap UEs as the network could configure an extended DRX cycle when the use case requires relatively relaxed requirements on downlink latency, reducing the UE power consumption during periods with large enough packet interval arrival time. RRM measurement relaxation. This is another high layer feature which is for RedCap UEs that can be enabled by the network. In RRC idle or inactive states, the UE is allowed to further relax neighbor cell RRM measurements in order to help reduce UE power consumption. And finally, reduce PDCCH monitoring by a smaller number of blind decodes in CCE limits. So these were the study done in release 17 and final outcome of these studies is on this screen. You can pause and take a look. So on your screen now is the definition of RedCap UE as per 3GPP release 18. RedCap UE is the UE with reduced capability, and what all qualifies for the reduced capabilities are these bullet points like bandwidth we have discussed in previous slide. Maximum mandatory support for DRB number is only 8, and there are some specification related to PDCP SN length support, RLC AM SN length support. Also, we discussed about the MIMO layers in our previous slide. And final point related to CA, MRDC, and some kind of other features which RedCap UE will not support. So this is the official definition by 3GPP release 18. You can find it in the document 38.306. All the UEs supporting or not supporting the listed functionality will qualify for the RedCap UEs. Let us also take a look on eRedCap or enhanced RedCap UEs. According to 3GPP, eRedCap is a new category of user equipment introduced and being developed within 3GPP release 18. eRedCap aims to further reduce complexity and resource consumption compared to the existing RedCap category defined in release 17. So given is the comparison of RedCap versus eRedCap UEs. You can pause and take a look. So enhanced RedCap UEs are developed under release 18 while RedCap UEs were specified in the release 17. Now let us have a look on few parameters related to RedCap UEs. The highlighted information element of UE capability message, which is sent from UE towards Gnode B, can be used by UE to notify Gnode B whether it supports RedCap or eRedCap and which specific feature it supports. RedCap config common release 17 or eRedCap config common release 18 is a configuration parameter standard specifically designed for RedCap UEs to inform these UEs about various configuration settings. These are transmitted via SIP1 from Gnode towards UE. Let us have a look at some of these parameters. The first parameter, cell barred RedCap 1RX release 17 or 18, indicates the UE whether this cell is barred or unbarred for RedCap or eRedCap UE with 1RX branch. We have similar parameters for the UEs with 2RX branches. The third parameter, half duplex RedCap allowed, indicates that this cell supports half duplex FDD for eRedCap UEs. Final parameter, intra-frequency reselection RedCap release 17 or release 18, controls whether cell selection or reselection to intra-frequency cell for RedCap or eRedCap UE is allowed when this cell is barred. The information element downlink config common provides common downlink parameters of a cell. If the highlighted parameter initial downlink bandwidth part RedCap release 17 is present, eRedCap UEs or RedCap UEs uses this downlink bandwidth part instead of initial downlink bandwidth part. And if this parameter is absent, the RedCap UEs use initial downlink bandwidth part provided it does not exceed the RedCap UE maximum bandwidth. Next parameter, feature combination. Let us talk about the IE first. The information element feature combination indicates a feature or combination of features to be associated with a set of random access resources. If this field is present, this indicates that eRedCap is part of the feature combination. The fields RedCap and eRedCap shall not both set to true. Coming to SIP4, this contains information about the NR frequencies and interfrequency neighboring cells relevant for cell reselection. The information element includes cell reselection parameters common for a frequency as well as cell specific reselection parameters. This message is used to transfer radio paging information. The parameter RedCap access allowed release 17 or eRedCap access allowed release 18 indicates whether eRedCap UEs are allowed to access cells on this frequency. Have a look at few more parameters introduced by 3GPP for RedCap UEs. Support of 16 DRB RedCap release 17. This parameter indicates whether the RedCap UE supports 16 DRBs. Next is support of RedCap release 17. This indicates whether UE is a RedCap UE or not. Next parameter is related to PDCP, which confirms whether the RedCap UE supports 18-bit length of PDCP sequence number, and similar parameter for RLC, which indicates whether the RedCap UE supports AMDRB with 18-bit length of RLC sequence number. All these are related to RedCap UE's capability. Now let us see how network identifies a RedCap UE during initial access. It can be done in two ways, via message 1 or via message 3. For a RedCap UE identification via message 1, RedCap specific random access configuration may be configured by the network. What does it mean? I think it can be implemented in the network using specific set of preambles which can be exclusively used only by a RedCap UE. Let us see how it can be done via message 3. As we know, in 5G, message 3 sends an LC ID, logical channel ID to the network, like a label saying what type of data it wants to transmit, control info or user data, to help the network prioritize and allocate resources efficiently. This method of a RedCap UE identification can be done during random access procedure via message 3 from a RedCap specific LCIDs. So unlike the preambles used in message 1, where we were using the pre-configured exclusive preambles for RedCap UEs, here we can specify few LCIDs exclusive for the RedCap UE. This slide gives the idea about comparison of various type of 5G devices. You can pause and have a look at this. So RedCap UE research and development is still ongoing. The development of RedCap UEs is an active area of research with efforts focused on enhancing their capabilities while maintaining their core advantages. So listed three can be the primary area of focus in the direction of research and development for RedCap UEs. First one is enhanced security. We need to explore lightweight security protocols with strong cryptographic foundations suitable for RedCap UEs. The second one is improved performance. Research and optimizing RedCap UE design to balance simplicity with capabilities like higher data rates or low latency for specific applications. And the final, advanced features. We need to investigate the possibility of incorporating features like network slicing or beamforming into the RedCap UE framework while maintaining resource efficiency. Thank you everyone for reaching here. And if you like the video, consider liking it and sharing with your friends and colleagues. Thank you again.